So children, I am going to explain very important part of P block. So P block in class 11th have to study about the physical properties of some of the elements, chemical properties of some compounds elements of group 13 and group 14. But before starting group 13 and 14, I am going to explain some very important points about the periodic table related to P block. So children, at a glance you have an idea that in periodic table we have this S block. Here there is a B block. Here there is a P block. So this is P block. This is S. This is B block, and here comes the F block. Here comes the F block. This is a very simple concept. Now, this S, this P, it is from 13 to 18 group. P is made up of 13 to 18. Here, group 1 and 2. And so here, 3 to 12. This is very simple. Now, with some more points, already you have seen in class 10. What is S block element? Element is said to be S block when last electron goes to S orbital or ultimate orbital. Valence shell, when last electron goes to S orbital, it is said to be the S block element. Similarly, when P block element is one in which last electron goes to P orbital. Last electron goes to valence electron goes to P orbital. And for this we have to write on the electronic configuration. Similarly, with the A block, last electron goes to F orbital. And children, keep in mind, this is a very common mistake that you write the small capital, but always you write down the small s, small d, small p, and a small f, because orbitals are represented. You already have seen in previous chapter atomic structure. Orbitals are represented by the small letters. Orbitals. You have seen the S orbital, the P orbital, D orbital, and F orbitals. So the orbitals are represented by small letters. Now, then identification. Very simple. You already know about the electronic configuration from Auger rule. So let it be, I am taking the case of any element. Let it be aluminium. Aluminium atomic number 13. Write on the electronic configuration. Just I want to explore you. So aluminium 1s2, 2s2, 2p6, 3s2, and 3p1. This is about the aluminium. So 2, 4, 6, 12, and 1 this 13. So here it is 13. This is the K cell, this is the L cell, this is the M cell, or this is the valence cell. So similarly, the electrons they enter to the valence cell. So here it is valence orbital or valence cell. So aluminium belongs to this. Similarly, we can take any other. Let it be chlorine. Chlorine is 17. 1s2, 2s2, 2p6, 3s2, and 3p5. We like this. So this is K, first step. This is second. This is third. So 2, 4, 6, 10 to 12 and 5, 17. That's why this chlorine belongs to P block. So this is very simple condition, and this has to be taken into consideration that entry of the last electron into the valence cell, it is seen as a condition, and we say the p block element. This is one point. Now the p block elements are in the three categories. P block elements are in three categories. That the p block is with the metals. Some of the metals are present, some metals are, some non-metals, and few semi-metals. Few semi-metals are present. Few semi-metals are present, and they are also called as metalloids. Semi-metals, or they are called as metalloids, like arsenic. So, and many more. So this is about the some basic point related to periodic table. Now, children, one more point, that S block and P block, S block and P block together, S and P block together called as members of representative group element. This is important point. Why the members of S and P block, they are called as representative group elements or simply representative? Because you have seen, just I have drawn in the periodic table, the larger portion of the periodic table is occupied by S and P. Once again I am repeating that the members of S and P block, they are called as representative elements or representative group elements because they constitute larger portion of the periodic table, and hence we use the term that S and P together are called as representative block elements. Now I am going to explain some of the basic points, some basic concepts about P block elements. Basic concepts about P block elements. So, because you will be able to understand very easily. And so, children, in this, first is, inert pair effect. Just I am giving brief introduction of this, and you will be able to listen an exact point. So, what is inert pair effect? Inert pair effect may be defined as the property of elements due to which, on moving from top to bottom in a group, the lower oxidation state becomes more stable. So, it may be defined as, on moving from top to bottom, in a group, lower oxidation state becomes more stable. Lower oxidation becomes more stable, and higher oxidation state becomes less stable. Or simply you can say that if any element exhibits variable valency. Let it be 2 and 4. So on moving from top to bottom, the stability of +2 oxidation state is more and stability of +4 is less. This is the exact point about the inert pair effect, and this is the definition. Now we have to know the reason, that what is the reason behind the inert pair effect. So actually inert pair effect is due to inability. So I am just writing the reason. It is due to inability of all the valence electrons to take part in bond formation. This is the reason. I will explain at the proper time when it comes. This is inert pair effect. Now the second point is catenation. So you have read in class 10th catenation. So catenation is very important property of p block, and this property of catenation is related to group 14. And so what is it? So it is, catenation may be defined as the property of some elements due to which the similar type of atoms are joined together in a variety of manner. So it may be defined as when similar type of atoms, same type of atoms are joined together in a group in different manner or ways. So it is catenation. So catenation is very important property of group 14. The group 14 elements or members of carbon family, they exhibit catenation. So this property of catenation, it is exhibited well by group 14 elements. Group 14 elements, you have seen in class 10. Carbon forms very large number of compounds, large number of hydrocarbons, large number of organic compounds. Why? It is due to tendency of catenation. There is diamond, there is graphite, there is fullerene. They all are due to catenation. So the tendency of catenation, this tendency of catenation, I am now going to explain catenation in detail. Carbon has maximum tendency of catenation, followed by silicon. Silicon has less tendency. Then germanium, then Sn and lead. They very poor or almost nil. So it is almost nil. Carbon has maximum, and this silicon, germanium, they have some little tendency of catenation. Carbon has maximum tendency. Carbon is most suitable element for the catenation, and tin and lead, SN sternum, PB plumbum lead. These are pure metals. You know, tin is metal, lead is metal. So they almost exhibit no catenation because they have very large size. Now, in this catenation, we have to see the region also. Why it is so? So region. So catenation depends on the size. So they have a small size. Carbon has very small size. So a small size is most suitable. The members of group 14, they have, you have read in class 10th, periodic properties. On moving from top to bottom in a group, the atomic size increases. On moving from left to right in a period, atomic size decreases. So the group 14 lies at a place. Group 14 lies at a place where there is the maximum tendency of catenation. So a small size, suitable electronegativity. Suitable electronegativity. Suitable electronegativity is there. So electronegativity no tendency to gain the electrons. So electrons are gained, and as a result, they are the maximum. So these are the two very important parts about the catenation region and so. Now coming to third point, coming to third property of this allotropy. Allotropy is defined as the property of some elements due to which there is formation of different forms. Different forms of elements are there having same chemical properties but have different physical properties. So, allotropy, it is defined as the property of some elements. Property of some elements in P block, large number of elements exhibit allotropy. Property of some elements due to which they have some forms. There are some forms of substances. They have some forms of substances having different physical properties, but chemical properties are same. They have same chemical properties, but physically they are different. You can say electrons differ from each other physically, but chemically they are same. Like in class 10, you must have read carbon forms electrons like coal, graphite, diamond, and fluorines. These are the allotropes of carbon. These are allotropes of carbon. So children, similarly, many elements we will see in class 12. Phosphorus, sulfur. Sulfur forms almost 8 allotropes. Here, tin and lead also forms allotropes, but they are not so significant. The allotropes of tin and lead, they are not so significant. Phosphorus forms, sulfur forms, arsenic forms, many elements forms allotropes, but coal, graphite, diamond, fluorines, you all have read in class 10. So it is there. Then coming to children, next point electronegative character. Electronegative character. Electronegative character means tendency to gain the electrons. So it is defined as tendency to gain the electrons. So as p block members are mostly non-metals. P block is dominated by non-metals. They have metals also, some. They have few non-metals, few semi-metals, and large number of non-metals. So the non-metals, they have tendency to gain the electrons because non-metals have a smaller size. And as you know, we move from left to right in a period. The atomic size decreases. And so when atomic size decreases, there is the increased tendency to gain the electrons, and this is called as electronegative character. So non-metals are electronegative in nature. And what is the effect? The effect is that they form anions. Anions are formed by non-metals, and region is a small size. Similarly, in the allotrope also, there is the reason that allotropes are formed due to similar size, and the size is such that in case of allotropes, there is the overlapping. Just we keep, some plates to cover some floor. Flooring is done, so we keep the tiles. So in the same pattern, there is the this allotropy and electronegativity, and so this is the condition about the this p block elements.